Hello, my name is Jared Skeens and welcome to the Zoom room. Now this video is actually part 2. We're finishing up the Pure Maths 1 May-June 2020 paper 11. We're looking at that. We've worked our way through most of it, but the video disconnected. So this is the part 2. If you happen to find this video and you want to watch from the beginning, then you need to go back and look for part 1. So this is part 2. We're actually almost to the end. We only have to finish up the problem that we're on and then the last problem. So let's get right to it. We're on this problem here with circles. So find the equation of the tangent to circle C at point B. Point B is 7, 4. Now remember, if your line is tangent to the diameter, it is going to be perpendicular in slope. So we need to find the slope of the diameter, slope from A to B. So I plugged in those values from our point A and B. So B was 7, 4. So our point A was -1, -2. Plug those in, change in Y over change in X. Y2 minus Y1 over X2 minus X1. We get 6/8 or 3/4. So the perpendicular slope for our tangent line would be -4/3. Plug that in as the slope. Then to find the plus C, if you choose to put it into slope-intercept form, I'm just used to doing that. You can use point-slope form if you're used to that as well. So I plug in the 7, 4 for my X and Y. Solve for C is 40 over 3, and you get Y equals a -4/3 X plus 40 over 3. And yes, if you use the point slope form, you could have Y, its tangent at B, so you could have Y minus 4 equals a -4/3 times, in parentheses, X minus 7. That would be fine as well. Moving on to part C, find the equation of the circle, which is the reflection of circle C in the line T. Now this one might be a little difficult for some of you, especially since this is new material and it's actually combining two concepts of new material. It is combining the new material of circles with the new material of transformations of functions. So kind of putting those two somewhat together, since the line was tangent, it means it touched B. So when you flip that circle over, B is still gonna be one of the points on the new circle. So B, I just made it become B prime, and the A will flip all the way over to the other side, A prime. And again, what we need for an equation is we need the center and we need the radius. So I just put A and B, or you could even put the center also. Notice from -1 to 7, you have to add 8. So our 7, if you add 8 again, will give you 15. Or if you're looking at the center, from the center to get from 3 to 7, you add 4. So if you add 4 to 7, you get 11. Add 4 to that, you get 15. If you look at the Y values, you add 6 here to get the 4, add 6 here to get the 10. Or if you're going with the center of 3, 1, you would add 3 to get the 4, add 3 to get the 7, add 3 to get the 10. So whichever ones you use to line that up with, you're looking for that symmetry in distance between the original circle and the reflected circle. Again, remember that your B and your B prime are the same coordinates, the 7, 4. And so your new center is going to be 11, 7, and your radius is still 5. When you reflect that circle over, you don't change the size in a reflection. So radius is still 5. We plug that in and we get x minus 11 squared plus y minus 7 squared equals 25. Okay, now to the last problem. Says, here we have equations 2y plus x equals 8. That's a straight line. The curve is y equals 8 over x plus 2. And it shows the diagram here, says C is lies on, or the tangent to C is parallel to the line 2y plus x equals 8, the AB line. Find by calculation the coordinates of A, B, and C. Well, A is the easiest. This is a linear line, and so it's going to follow the y equals mx plus c, where c is the y-intercept. So if we take that right here, solve for y, we get y equals negative 1/2 x plus 4, meaning the 4 is the y-intercept, and of course the x value is 0. So 0, 4 is the coordinates for A. For B, A and B are both intersecting points between the line and the curve. So if we set the line equal to the curve and multiply by the x plus 2 to the other side, just do your binomial distribution, you get a negative 1/2 x squared minus x plus 4x plus 8 equals 8. Cancel the 8s. Negative 1/2 x squared plus 3x equals 0. Factor an x out. Set each one equal to 0 and solve. The x equals 0 we already have. That was our A value. And then the x equals 6 is the new value for B. Plug that into the original, or I plugged it, you could plug it into either equation. I plugged it into the line. And you get a y component of 1. So 6, 1 is your coordinate for B. Then for C has to do with slope. So slope is the derivative of the function. So we take the derivative of the function, multiply the exponent to the front, subtract 1. Even though this is expanded, the derivative of the inside is only 1, so it doesn't affect anything. And we know that this slope is equal to, or is parallel to, that means has the same slope as the line. And our line has a slope of negative 1/2. So we set that equal to the slope. Again, your negative square means that, or the negative 2 means it's on the denominator. Cross multiply, solve for x, and you get x either equals 2 or a negative 6. Well, x can't be negative because we're on the positive side of the x-axis. So that means x has to equal 2. Plug 2 in to the curve, has to be the curve. C is not on the line, so don't plug it into the line. Plug it into the curve and plug 2 in, and we end up with also a value of 2 for the y value. So here's our A, B, C values that they asked for. Now, find the volume generated when the shaded region bounded by the curve and the line is rotated through 360 degrees about the x-axis. Now, this one happens to be a little rare. In the last probably 10 years of past papers, I've only seen, I think, 2 washers examples in the past papers. So here we have it again for the start of our 2020 syllabus. What I mean by a washer is this. When you rotate the shaded region around the x-axis, notice when you make a circle, the shaded region, there is an empty part in the middle. In other words, the whole section is not solid volume. There is a volume, but there is a hole in the middle of the volume. So it's almost like some sort of a vase with the empty spot in the middle. So for a washers, we have to do the radius, which is from the x-axis to the function, we do the normal disk method, the normal pi r squared delta x method, but we also have to subtract out the inner radius because it's a hole, it's empty. So the formula for that is pi, we're going from 0 to 6, 0 to 6 being 0 on the x-axis, out to 6, from A to B, 0 to 6, here's the 0 and 6. That's the bounds of integration. And here is the outer radius squared. The line was on the outside. That's the outer radius squared minus the curve, the inner radius squared, and then dx. So this is our washer's formula. So first, remember the mental process when you're dealing with integration. Simplify, integrate, evaluate. Simplify, integrate, evaluate. So now that we've set it up, we need to simplify by carrying out these squares. And so I squared this. It is possible that you don't necessarily have to. You can integrate directly, but you have to deal with all the expanded form if you do that. I went ahead and squared it out so that it was simpler terms to work with. This square distributes to the 8 and to the -1. So that gives us 64 and an x plus 2 to the -2 dx. Now we integrate where you add 1 and divide by the number. So we add 1 to 2, we get 3. Divide by 3, we get 12. And you go through each term. This one is kind of expanded form, -2 times -6. Integrating, so you add 1, you get -1, then you divide by -1, you get positive 64. So then the inside is just 1, so that doesn't affect anything. Now we evaluate from 6 to 0. Don't forget top minus bottom. So we plug in the 6, we get these numbers, minus, we plug in the 0, we get these numbers, which gives us pi times 50 minus 32, which is a total of 18 pi. And that is the end of our Pure Maths 1 May-June 2020 series, paper 11 for the new syllabus cycle. And again, this was part 2. If you missed part 1, you can look for it. There's a video for that. Unfortunately, it got disconnected there towards the end. So this is the part 2, the end of the video. Thank you again for watching, and hope to see you again next time.